Hello and welcome to Java Tutorials with your man, the OC man. He is the man. Today we're going to take a look at variables. We're going to look at how to initialize them, and how to create objects. Give a little wet your whistle with some object stuff because that's what Java's all about. And we're going to look at some arithmetic, how Java does some arithmetic for us. And we're probably going to freelance a program at the end looking at strings, which is a special kind of object, and see what we can do with it. Maybe print some stuff out, get some information out of it, all that good stuff. All right, so first thing we're going to work with is variables. So let's take a look at variables. There's a lot of times in a lot of programs you want to be able to store data. I mean, that's big. You want to store it for a later time in the program to use it later. Those are called variables. In Java, a variable is essentially a set spot in memory that Java has set aside to store your value. So when you want to create a variable, there's a spot in your memory that has to be selectively kept just for your value. Now in Java can't just set aside memory and say, oh, you want to just use anything here, huh? Java's got to say, listen, man, I got to know what you're using this for. Is this going to be an integer kind of number you're going to put in, a negative whole number to a positive whole number somewhere in there? Or is it going to be a floating point value? Is this going to be a value that I'll have decimal place in it? Or is it going to be, for instance, a character like A, B, C, D, E, F, G, or any of the other characters that it has? It wants to know. So when you're writing a program and you want to keep a certain spot in memory open so you can keep value stored in it, you have to declare it. The way you declare it is very simple. You declare the type it is. Okay. In this case, we're declaring an integer, int. That's an int is a reserved word. You cannot use it for anything else. Cannot be used for a variable name. Now, for us as humans, we don't want to reference memory as int A1BBFX409. You don't. Memory addressing is really kind of annoying for you. Java handles that for you. Java lets you just say, listen, instead of you having to deal with the actual address of memory, why don't you give it a name? So we give it a name. We say, okay, set aside some memory for an integer, and I'm going to reference it by total. You don't care where Java stores it in the RAM or wherever. You just know that whenever you want that spot in memory, you call it total, and that spot in memory will house an integer for you. Okay, and then you can just put a semicolon, and now Java has set up a memory location for an integer that you can reference by the name total, an identifier called total. You can do multiple variables at once. You can say int count, comma, temp, comma, result. All three of those will get initialized into three different memory spots that are all integer type memory spots. And you can semicolon it after that. So it's pretty easy. I mean, there are integers. There are floating points, so you could call this float here, or double. You could say double. Double is another type of a floating point value. We'll go into the differences later. But so these just kind of declare for you, and there are lots of ways to do it. Variables can also be given values to start off, because a lot of times you may want to start with a value. In fact, I'm going to tell you right now, it's a good rule of thumb that you always initialize a variable to a number. Okay? Do you always do that? Maybe later on in your programming career, you may not do that for certain decisions that you want to do, and that's a case-by-case basis. But generally speaking, you do want to assign a number to it, even if it's 0 to start. So if you want to set aside some memory for an integer and you want to call it sum, even if you're not using it right now, you may want to just start it off at a certain number. So you assign it, that's what an equal sign means, assign a value of 0 to it. So it takes this integer 0 and assigns it back to the sum, which is a spot in the memory. So that spot in the memory now is the integer 0. Right? You could do multiple. When you declare multiple, you can also assign at the same time. So you could say, hey, make a area in memory called base for me to call it base, and it's an integer type, and assign the value of 32 into that. Also assign 149, assign it to the max memory location. Okay, so let's take a look at that in actual programmatic terms. So here's an example from your book, the piano keys. Okay, you'll notice normal things, public class, name of the file, piano keys, good old commenting like we always like to see, public static void main string, args. All right, we're done sitting there playing with that, folks. You guys should just know that. So we set up an integer called keys, and we're going to assign it the value of 88 to start off. Okay, so this declares keys as a memory location, and it declares it as an integer type. So this is declaring. And since this is occurring right here, this is called initialization. Declaring initialization. Right? And so you're initializing the original value of keys to be 88. You're assigning it to keys. Then I could just print it out later. So we'll do something we've done always. System out print line. You put a string literal in here. Piano has, hey, there's that plus. That's concatenation plus. And then we see now, not in quotes at all, we see the word keys in here. What that means is that they're going to print out whatever is in the memory location of keys. So here I have keys, and it's going to print out 88 because it's going to go to that memory location. It doesn't print out the word keys. It goes to the memory location of keys and says, oh, hey, look, there's a number of 88 there. So then it gets 88 and puts it right there for us. And then we concatenate on the keys here. Now, why this doesn't get the memory location is because it's inside of a double quote system, which is our string literal. So it's saying, don't go get the keys value. That's literally what I want printed out. I literally want you to print out keys. Don't go get the memory. Literally print it out. All right. So if we compile this and then we run it, a piano has 88 keys. You can play around with this. We could start this off as 108, recompile, and run. And now it says 108. All right. We could also change it later on. If you want to change a value later on, it's something easy to do. Keys equals 10. The reason I did not need to put int here was because keys has already been declared. That memory location is set up and it's good to go. In fact, you can never change what's stored in that memory location anymore, in the sense that it will always be integers. You cannot make the identifier keys reference anything else anymore. You can change what's in there, but keys cannot be used as a name for something else. So if you want to make another variable, you cannot use the name keys anymore. All right. Now, if I want to print this back out, I'll system out print line. We changed that value to keys. All right. And so I'm saying, well, we change it to the value of keys. And remember, Java reads top to bottom, left to right. Now, that left to right does change just a hair when we do some arithmetic, but that's pretty much what you're looking at. So in this case, you may say, why doesn't it print 108 out down here? Well, because before I get to here, the program has already gotten through the execution of this line, which set it to 10. Why doesn't it print 10 here? Because it reads top to bottom. So it read this part first, 108, and then it reads this next, and since it's reading top to bottom, it doesn't know that this has happened yet. So keys is still 108. So it prints 108 here, 10 here. So we'll compile and execute, and you can see a piano has 108 keys, but we changed that to 10. And that's cool. You can change it. You can manipulate what's stored in the memory. You can change it at any time. That's what makes it varying, aka a variable. So that's awesome. You can do that. That is really, 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 really cool. Okay? All right. So let's talk about this assignment a little bit more because I want to be clear about what I'm talking about. Assignment is what this equal signs means. All right. In math, I know it always means equals, like x plus y equals 10. That means the addition of x plus y is the value that you say afterwards. You could think of it the same way here, but really it's better to think of it as assigning, as in you are saying, hey, 55, 55. You are going to go to the total area in memory. So you're saying 55, you're assigned to the total spot. So get your butt over there and stay in the total area. Okay, so that spot in memory, you stay there. Because equals can throw you for a confusion once in a while, because we're going to use equals in a different way here later on, especially in Chapter 3. So assignment is the last thing that's evaluated. So this is right to left evaluated. So whenever you have like a variable assigned and then stuff over here, whatever's on the right side gets done first. Now in this case, you might say, oh, what do you mean gets done? It's just 55, duh. Well, yeah, okay. Right here it's just 55. Later on down the road, we may put an equation there. 55 plus 22. And so, whatever's on that right side is always done before the equal sign. All right? And it's always happened. Now, let's say total had something in it. It gets overwritten. You saw that over here in the piano key. That 108, bye-bye. When it came here, it was like, see ya 108. Java says punt and gets it out of there. All right? So now it becomes 10 after that, and the 108 is no longer there and no longer will be there. The only way to get 108 back is if later on you say keys equals 108. That's 201 to be exact, but there's 108. Okay? And then you could print it out again. But that's the only way to get keys back to 108. No other way to get it. Okay? All right. So one of the examples in your book is this geometry one, and they just show you where you can change it, kind of like what we just did. They start saying to declare a location in memory as an integer location, and you want to call it sides because you don't want to sit there and have to remember, oh, the location of memory is 00856AA4. Like who? I don't remember that. Sides, I can remember that. So sides equals 7, and so we're going to then print out sides, and then we're going to assign sides again to 10. So 10 is assigned to sides. The 7 goes, see you, bye-bye 7, does not happen anymore, not there. So then when I print sides out here, it's now 10. Then I assign it to 12, so I say 12 assigned to sides. Again, boots out the 10, so then a dodecagon has 12 sides. So if we compile this, we should see heptagon has 7, 10, and then 12. So if we run and execute, there we go. We see that it's been assigned. So assignment is really powerful. It's something that is really useful in our using of the Java language. Okay. Just to let you know, there are some times you want to keep values constant throughout your program, and you don't want to accidentally change them ever. Okay. Also, there's some memory advantages to this. Listen, in honors, we're not going to talk about it. But if there's a value you know that's never going to change. Take, for instance, let's say you're writing a student class, and you know that the maximum amount of students you'll have in your class are 10, or you're writing a program that the max value of something you want is 10, okay? Then you could declare what's called a constant, okay? A constant is just like what you think in physics or chemistry or anything like that. A constant means the number never will change, all right? So what we do is, it's just like declaring a variable in the sense that you say, hey, I want to make an integer, and I'm going to call it something, okay? See, underscores are used in Java as like spaces, because you can't use a space in an identifier. We use the underscores there. So we say int min height equals 69. So we're assigning the value of 69, assigning the value to min height. However, you're going to notice this final in front of it. What that means is that value is finite. Sorry, I don't care what you try to do anymore. It is going to be the value 69 no matter what you do. It'll always be 69. No if, no and, no but. It is always 69. In fact, if later on in the program you decide to write min height equals 50 now, the Java's going to be, you hit compile, what are you doing here, pal? You can't do that. It won't look like that, but it pretty much will yell at you in that sense. And you can't do that anymore, okay? Because it's a constant, all right? And you notice that you're starting to see some names here that have certain ways we write them. Constants, we generally write their identifiers in all caps to say, bam, that's the way it is, okay? That's what how we do constants. Variables that are primitive types are usually all lowercase. They can have an uppercase if you put a second word in there. So if this is like total value, I might type in total value and make the capital V. Naming convention says at least the lowercase on the first one, okay? But it doesn't matter. Really, again, that's a naming convention as we suggest. It's a standard we suggest. And so when everybody talks to each other, we can look at a program and identify that. All right? So let's talk more about what you can define things as, because that's really interesting. Like, what else can I define? Are integers the only thing I can have? No. There are actually more than one way to actually say you want to do an integer. Either a byte, a short, an int, or a long. Okay? If you want to know what the differences is, right now, it's just how much memory does it want to set aside. You might say, I don't care. Well, I want to set aside, I want to be able to put whatever number I in there. Well, remember, memory has a finite space. So if you want to set up that memory, you could set up a very large finite